Welcome back to Refactoring Bailey Rules. My name is Tom. As you probably know by now, we're taking a 20-year-old Mac application and trying to modernize it. Turns out, in some of the recent work I've been doing, I've really broken a lot of it. And that's not really unexpected. The reason for that is there's a lot of bad code floating around in the application, and it's doing a lot of nefarious things that, well, I shouldn't say nefarious. It's doing a lot of things that are not to my current standards. So what I'm trying to do right now is to get the code in place where I can start fixing some of these issues. And that I was also taking a little bit of a break to do something a little differently and somewhat like a palette cleanser for myself. And that is migrating my graphics code to Swift. It was intended to be a palette cleanser, but it ended up being a lot of work. So let's talk about it. As I mentioned, the app is broken. It's got some problems reading and writing files. So I've been building out this more overly engineered, overly complicated way of reading and writing the existing SQLite data file. And as I mentioned, that's probably a bad idea. And yes, it was. It was a bad idea. And doing this rewriting, I found that a lot of the code that I was writing was incompatible with what I had. That's probably a good thing because what I had wasn't really doing the job it was supposed to do. So again, as I mentioned, I was working on refactoring out the document and replacing it with something more modern, but I'm, again, taking a break and moving somewhere else as a balance. I want to work on layers and graphics for a bit. So right now we're just focusing on the graphics. Hopefully the next episode after this one will focus on layers. Along with that, I've also been using a lot of AI with varying degrees of success. So primarily I use a lot of the free models that are available in Windsurf. Windsurf has a lot of models available to it. If you pay extra or pay the actual fees, you can get wide access to various different kinds of models, and it's a very good platform. So while I was working on this project, as part of the project, I decided to make a step, whether or not I'm going to go with Windsurf or something else. In the end, I decided to go with Claude Code. There was a big toss-up between Windsurf and Claude Code, and I just picked Claude Code for a variety of reasons, which I won't get into here, but it just seemed like a simple solution for now. So I'm only paying the pro level plan. There's a higher level plan that is like $200 a month, and there's also an API plan where you just pay for what you use. I really couldn't decide what I wanted, so I just went with the basic pro plan for Claude Code. Okay, getting back to the whole concept of layers and graphics. The graphics, of course, that I'm talking about are the actual diagram you see on the right. They are in part controlled by the layers that you see listed on the left. So there's graphics that are tied to each one of these layers. For example, the layer that says test is actually the text layer that's on the screen. The grid is that round grid system. The R test is our data. So the black filled in area is a petal style rows diagram. So those are our data. And then there's a last layer called statistics for our test, which is the arrow and the error bars. So this is a relatively simple diagram, simple way of connecting these things up conceptually. The code is not pretty, as I discovered. So the basic way this is structured, each layer has ownership over its graphics that is related to it. So that grid has all the lines and circles attached to it. And so the rendering process goes through all the layers and then draws each thing out in order. So you have a good idea what the drawing order is, and you can rearrange that if you want. But this current state of the graphics themselves is a little complicated. As you can see, we have a superclass called the XR graphic, which handles some of the stuff that all the graphics will handle, with the exception, if you look to the right, is the LITM arrowhead. So if you remember, the statistics part of the diagram had a little arrow on it. That actually draws the arrows, or the arrowheads. And it's not a subclass of XR graphic. The LITM is kind of a giveaway that it's something different. The reality is that was from another library. I decided to pull it out of that library and make it a part of this app. And you can see, looking at Xcode graphic, we have a whole bunch of subclasses that do different things. So we have a circle and a subclass of circle label that draws the circles. We have lines, and then the rest of them are different kinds of data plots. The kite style, the petal, which I showed you, a dot deviation, and a histogram. So those are all different data plotting styles. Now, of course, these are all Objective-C classes, but they're actually Objective-C 1.0. That makes them a little rough to work with. The newer Objective-C code is much, much better. Now, I did use AI to generate replacements for all of these files. So I had them created, and they're in the repo. Before we really deal with that part of it, let's talk about some of the strategies I have for different ways of converting these types of files. One is rewrite them. We can preserve the functionality or not, but it's not the ultimate goal of a rewrite. A rewrite is to make it better, to make it function better, and it may not necessarily have the same functionality. And that final code should be up to your current standards, whether or not it's one way or another. It's got to be up to your current standards. In this case, it'll be my standard. But rewriting is actually high risk in terms of effort, time, and bugs. It may take a lot of effort, it may take a lot of time, and you can introduce brand new bugs that you didn't have before. So that's one solution. Another one is the translittle conversion. It's exactly the same, but in Swift, which is what the AI will do. So you just take that code, just modify it or rewrite it in Swift. And the problem with that is you're at high risk of preserving bad code, especially if it's being done by the AI and the AI isn't taking it upon itself to make things better. Probably the best solution is via refactor. First step, write tests, clean up the code, modernize it to modern Objective-C, and then do the conversion. This helps us keep the same functionality, the same expectations as the current code. That means we're not rewriting it, we're just refactoring it to make it a little better. And we're at moderate risk of introducing new bugs, but the thing is we've tested things, and we should have a good set of tests around things so that when we make changes, we know that we made a mistake or not. But we also have a high risk of taking a lot of time. Writing a test takes time, updating Objective-C takes time, switching it back to Swift takes time, and both of those solutions aren't the best thing. So in terms of time, just do a translittle conversion using AI would be the fastest thing, but we have no idea if that's good. So the test part is super important. Conversion process I took in this case was more or less this refactor process. Wrote tests. I had AI help me, but it wasn't very successful to write tests to document the functionality more than anything. The tests were the documentation because I had no idea how some of this stuff really worked. It was very complicated code and very hard to follow. We wanted to modernize the Objective-C code once the tests were in place so we can make changes and be confident that we didn't break anything. And I will tell you that on occasion, the AI, when I asked it to make a change, it did something a little weird and broke the tests. Once I stabilized the code, so it was drawing correctly, it was passing the tests, then it was time to make a Swift implementation. That the AI could do reasonably well, and then you can run the tests and know whether or not the Swift implementation worked or not. Now, there will be some changes in the tests because the Swift implementation is going to be called a little bit differently, but it should work. Now, long term, we do want to rewrite. This way of drawing that I have here is not ideal. I don't want Objective-C or Swift classes that do the drawing. I'd rather have structs. I'd rather have a factory that builds the objects. Since these are classes and the way it was designed, these bits of graphics can be mutable. And I want to move away from that. That's going to require rebuilding the graphics. But as of right now, that would be a bad decision. I've made enough bad decisions already, so let's not do that. So a bit about writing the tests. I went ahead and used Swift testing. I really like Swift testing. It's not perfect. It's not mature yet, but I'm really liking it in general. So I'm using Swift testing. AI doesn't do very well with Swift testing because it doesn't know it very well. It's only been out for about a year at this time, so a lot of the models don't have a lot to train on. So we can't expect the AI to do particularly well. The other issue is none of this code was written to be tested. The code would have been a lot better if it was tested from the beginning. But this was largely before much unit testing existed for Mac or iOS. And one of the key things is there was this weird function or method on all of these classes called graphic settings. And what that method did was it accumulated all the settings for that particular graphic into a dictionary and returns it. It's used for other things, which I'm not really happy about. But the lucky thing for me is that since they were there and they were detailing all the graphics settings in the files, it was a great way to use as testing validation. So it's a weird thing that this weird function actually turned out to be useful for testing. So I'll take a look at the original version of graphic settings and what I end up with graphic settings, because it's kind of a good example of some changes we'd made with refactoring. I did find some bugs here and there. We made those fixes, but having the tests in place made those bugs a little less hairy. A lot of those bugs I never knew about, never really encountered, but that's okay. Let me give you a quick example of a couple of things that I had to look at during this transition. So this diagram is showing the three different states I had for refactoring these files. So the first one was the original Objective-C 1, the Objective-C 2, and the Swift versions. And this is about properties. As you can see on the left, most what we call properties today were instance variables in my graphic classes. That means you had to write your own accessors if you wanted to have them easily accessible from the outside. That was not something I really wanted to deal with in terms of writing tests or anything like that. So that's where that graphic settings method came in handy, because that would give me all these bits of information in my tests without me having to change this at all. But when we switch to Objective-C, we now have properties. Properties can build up all the accessors automatically for you. So some of these were going to be in the header, in other words, public properties. And some of them would still be private, and they were left as private ones in the .m file or the implementation file. So this transition was actually pretty significant, going from one to the other. And then finally, we switched them to Swift. And that's where a couple of things became more important. For example, we had to know exactly the size of the data. So tick type was actually an int32. An int in Objective-C is essentially an int32 in Swift. And one thing I'm showing there is I'm having custom getters and setters here for doing various things. As you can see, I don't show that on the left. So let's talk about accessors for a minute. So I would have to write in Objective-C 1 my own methods. Those methods I could have inside those accessors have it do something. So if I change the tick type, it would have to re-render the graphics, or reconfigure the graphics and redraw them. So that would have a function that would actually do that inside the accessor. Now, properties in Objective-C 2.0 and further could actually have accessors in them, and you could have custom accessors if you want. And I was too lazy to write custom accessors, so I set up key value observing. So key value observing, I think, may have been available at the time I wrote it, but I did not understand it at the time. but it gives us a way to observe changes to properties. So if a property changes, we can then observe if that change takes place, and then we can update the code accordingly. But when we go to Swift, we can just do that with custom getters and setters. Now this one's a little bit exaggerated because I think AI wrote this one, but I could have just kept it as a did set and move on or something like that. Okay, so that was a couple of highlights of things that had to change for this all to work. So as you can see on the left, I now have the entire process complete. I've created the tests and I have the objects as Swift files. There are changes that's going to happen. I'm going to get rid of all of the XML file support. I don't think anybody's used that file support for upwards to 15, 20 years, so I'm not going to support it anymore. However, I could bring it back if I feel like I have the time and energy, but as of right now, I'm not going to do that. Secondly, this particular migration from Objective-C to Swift is not the end answer for these types either. And that is because these types are doing way too much. They are basically configuring themselves. All this work in here is not to actually draw the line. A lot of it is to take in information, know about the layout of the canvas, be able to recreate the lines, and then draw them when necessary. It's doing way too much. I would rather move to a factory system where I have a specific factory that knows how to build everything and then create the graphics for the layer, and I would just hand it to the layer and the layer would just have these graphics to draw, and it would not manage the configuration of all that itself. I want to simplify this mechanism. It's not going to happen now because we have way too much that is too delicate to move forward on that. Now, my original plan was to go from the graphics, which are owned by layers, to the layers. And these are the layers. As you can see, taking out the tests, or excuse me, the Swift conversions that I did earlier, and I hope to do these again. But one thing that this particular piece of work has convinced me of is that I need to go back and complete being able to read and write to my SQLite data file. Dump all the XML stuff to get that out of my way, and then just focus on being able to read in the data and being able to plot the data. That's an important thing, because if I can't actually have the app work, I can't actually see what I'm doing and making sure that what changes I'm making actually make sense. So that's going to be what I'm going to be doing next time. Taking the time to get that reading and writing stuff working properly. If you have any questions or comments, leave a comment down below or send me a note. My name is Tom, and happy end of the summer.